I'm Cindy Kelly. I'm in Alexandria, Virginia. It is January 9th, 2017, and I have with me Milton Levinson. My first question to him is to please say his name and then spell it.
Well, my name is Milton Levinson, no middle name, Milton, and Levinson is Levenson.
Terrific. At any rate, let's begin with the beginning. Tell us, if you would, when you were born and where, and something about your childhood.
Well, I don't remember much about it. I think I was present at the time, but that's a long time ago. I was born in St. Paul, Minnesota, lived there till I was 5 years old. That's a long time ago, 1923. By the time I was 5, the Depression had started to hit, and things were not in good shape. We ended up moving to Northfield, Minnesota, which is where I finished my growing up and left there to go to the University of Minnesota.
So, do you want to mention what your father's occupation was? And
My parents were both immigrants. My dad came to this country at the age of 18 to escape being drafted into the Russian army. At that time, if you were Jewish and drafted into the Russian army, it was probably for a 25-year term as a private. He learned the trade as a felt maker to make ladies' hats, felt hats. Just prior to the big crash of stock market, ladies' felt hats went out of style. He lost his job, was unemployed, had no skill, no trade. He was literate, but he was self-taught in this country because he came here speaking Russian, Polish, and Hebrew, but he never went to school. He had to immediately go to work. He did manage to save up enough money to bring other members of his family over. My mother came to this country when she was 13, was put into a kindergarten because she spoke no English, was there just 1 year, and then had to quit to go to work in a sweatshop as a seamstress. And so that was our background. Some friends had an old house in Northfield, Minnesota. There had been a junk dealer there, nobody that was there now, and they loaned my parents $200 to buy a used truck and for capital to get started. And that's where I grew up.
oh, that's marvelous, amazing. Was your mother also Russian?
Yes, they were both, well, it's what now is Belarusia. At various times, it's been Ukrainian, Lithuanian, Polish, German, Russian. Both of my parents came over before World War I.
Wow. And from that humble beginning, how did you get to the University of Minnesota?
Well, my parents were not much help. I really had no intention of going to the university because there wasn't any money. It was barely enough to get food, etc. These were very serious times. But a couple of high school teachers insisted I had to go. At that time, in Minnesota, if you were a graduate of a high school, legitimate graduate of a high school, you were automatically accepted at the University of Minnesota. There was no applying or anything. But I had no idea what I wanted to be. I had no idea what various fields amounted to. My parents were no help. One high school teacher said, well, when you go up there, you sign up for chemical engineering. And I said, why? What's that? And they said, never mind. It's the most intense program there is. At the end of 2 years, you'll have as much physics as a physics major. You'll have as much chemistry as a chemistry major. You'll have as much math as a math major. And then you can decide by then, you can go into any field, pre-med, pre-law, anything, and you won't have lost a quarter. That was the critical thing. Today, kids start out and they change their mind, they change fields, they go an extra quarter, maybe an extra year. There wasn't any money for that. And I most of the time worked 3 jobs. I worked at the switchboard of the University Hospital from 4 to 12. I worked cafeteria for my meals, serving breakfast, and I worked in an analytical lab for one of the professors. He had a contract to analyze pieces of German shells and stuff for what alloys were being made. And they were good jobs, 25 cents an hour at that time. And the way it worked at the University of Minnesota, this meant that the freshman classes were huge. It might be 500-600 students. But everybody in that part of the school had to take 3 quarters of physics. And each quarter, they posted all of the grades, and a red line at the middle, 50% of each class flunked. So after 3 quarters, you were down to 1/8 of the students. They had to accept everybody, but they had to have a way to reduce them for upperclassmen. So you really didn't worry about your grade, you just wondered whether you were above or below the red line. And World War II came along, and then you couldn't change your field anyway, because you would lose your draft deferment. So I ended up, and we started going to school 12 months out of the year, and so I ended up finishing up in chemical engineering.
You mentioned earlier that you had one professor that was turned out later to be instrumental in the Manhattan Project.
Yeah, I had physics from Near, who at that time, what was discussed on campus is he had succeeded in separating uranium isotopes in a small centrifuge. And later I can tell you when it fits into the story, how it impacted me. It had nothing to do with college. While I was at college, it just made something later in life possible because you can put 2 and 2 together. Sometimes you get 5, sometimes you get 6, occasionally you get 4, and it worked out. People came to the university to interview students, and I had one offer that was $25 a month more than any other offer. And $25 a month when you're making 25 cents an hour is substantial, so I took it. I had no idea what it was or where it was, but it was the Manhattan Project. And that's how I got to Decatur, Illinois, to be working, I later determined, on barrier for the diffusion plant. But there was no uranium being worked on at Decatur. Used things like mixtures of xenon and krypton to get gas properties, and there was very little in the way of security because there was very little information. A few months later, somebody in Washington with infinite wisdom decided that if you were under 22, you couldn't get a technical deferment, so I got drafted.
How old were you? How old were you?
I was born in 23,
and
this was 44.
40.
I was 21.
Okay.
When I went through personnel to leave Hudai Hershey, there were no GIs at Hudai Hershey at that time. When I left there, they handed me something and said, "You may need this. This is so you memorize it." And it was an Army regulation which allowed an enlisted man to disobey a direct order of a commissioned officer if it involved something the officer was not cleared for. I had no idea how that was relevant to me, but they were very important and said to remember that, you may need it. So I got into the combat engineers, took the 30-day crisis training for combat engineer, and we were probably headed for the Battle of the Bulge. And got transferred down to Louisiana, and by then everybody knew that's where we were going, or we thought that's where we were going. And the commanding officer calls me in, and on his desk is a stack of paper, and there are envelopes all with big wax seals, and some writing on the top one, and discovered that he was not allowed to open them. The top one was a date, a time, and a train number, and he was to put me on the train. When I get on the train, I tear open the envelope and get my train ticket, and it tells me where I'm going. I get there, I open the second envelope, and that tells me who to call and what to do. Third envelope was just my Army records. He spent about 45 minutes trying to figure this out. He said, this is very unusual, and he said, the return address on the envelope is the Manhattan Engineering District, and I've looked that up in Army records, and it's a surveying outfit that was organized prior to World War I. The Army did not make up a fictitious name for the Manhattan Project. They took an old dead unit. And he said, when we get to Europe, I can probably, things cool down, I can probably get you assigned to a refinery attachment in North Africa, and you could be in your field. And now I begin to realize something is going on, and I just didn't trust the Army. So I said, no, I'll take the transfer, sir. And there were 3 stacks on his desk. I've subsequently have reason to believe the reason he was so confused, the stacks were identical, but he was putting people on 3 different trains. One was somebody going back to Los Alamos, in the same category I was in. So he gets put on a train going west. One is going back to Columbia, so he gets put on a train going east. I'm going back to Decatur, so I get put on a train going north. You can imagine the confusion in his case. Now when I get back to Decatur, during this period, there's a number of GIs, because the Army has been canceling ASTM and ASTP programs and assigning them to the Manhattan District. And so there were some there. And clearly, this is something a hell of a lot bigger than anything I understand. So the first time I can get a 3-day pass, I go up to Chicago. The John Carrar Library was the top technical library in probably the world. And I spent a half a day there, came away with the conclusion that it was a nuclear bomb we were working on, including uranium isotope separation. And it was because of the background of the physics of NIR that I could even get there. The other thing that's interesting, and I've subsequently learned that the Russians used it, I thought it was my idea, but it clearly wasn't. A lot of people have done it, is the way to find out what's going on is what's not published. If somebody's been publishing in a field for years and all of a sudden he stops publishing, it means he's had a breakthrough or it's important. And so when I got back to Decatur, one of my friends, I thought, who had been at Columbia, I got him aside and said, Alex, is this what it's all about? Well, now I'm an unguided missile. 2 days later, I was on the train to Oak Ridge. When I got to Oak Ridge, there was a sort of a problem. All of the GIs coming there were coming in groups from ASTM and ASTP programs. Most of them did not have degrees. They had 2 or 3 years or part training. So most of them end up as super technicians doing leak detection, doing health physics, etc. My education was done. They didn't know what to do with me. There was a man by the name of Major Murphy at the Oak Ridge National Lab who was a chemist from DuPont, a chemical engineer. When he was drafted, he was assigned by DuPont to the Manhattan Project. So they called him up and said, can you use a chemical engineer? He said, sure, send him out here, we'll find something for him to do. So that's how I ended up as kind of a loner and got to the Oak Ridge National Lab. They were just starting a project. Los Alamos had decided there was another material they needed, and it was a crash basis. People worked construction 24 hours a day building this new facility, and I was put into that group. And before the year was out, I was in charge of the group. And one of the most frustrating days of my life, inside the fence where DuPont was running it, they didn't care whether you were military or civilian, and if you were military, they didn't care about your rank. They just, what could you do? The amount of responsibility delegated down was incredible. In less than a year, I was in charge of the facility, and the pressure was tremendous. So there'd be days at a time I never left the building. I'd sleep on coveralls under a desk, and eat in the cafeteria. And after we successfully made the first batch of material and sent it off to Los Alamos, my boss called me in. It wasn't Major Murphy. My immediate boss called me in and said, "Milt, you've done a hell of a job. We've sent notice to Grove's office, and they're going to promote you from private to private first class. But we know you're really being overworked. So we're providing you with an assistant, an Army major." So all day long, I was boss, and we went out the gate at night. He went to officers' quarters, and I went to the barracks with 47 other guys. I was sort of cynical, but it was a great and incredible experience. And the priority that people were given. I was a punk kid, barely a little over a year out of school. I'm in charge of a major facility, and everything involved: the safety of the employees, the analytical lab that went with it, the safety of the facility. There wasn't a lot of places. There were people that provide help if you needed help, but that's one of the things that impressed me the most, was that the delegation of responsibility. The really critical thing, the thing which we've lost, is that responsibility and authority were always delegated together. We now have a system where people in the Department of Energy have the authority but no responsibility. People at a national lab have responsibility and no authority. That doesn't work. But the Manhattan Project, at least I don't know anything about K-25 or Y-12 or Hanford, but I know that at the Oak Ridge National Lab, they were delegated carefully together. And that took us to the end of the war. After the bombs were dropped and the Smythe report came out, everybody knew then what was going on, and the military started planning for the tests at Eniwetok. The military people at Oak Ridge, and probably the others, were told that if they signed up for the tests, as soon as the tests were over, you'd be discharged. But since you carried very few points compared to the thousands of combat people coming back, if you didn't go to the test, you'd probably be at Oak Ridge for a number of years. But again, I was pretty skeptical, so I didn't sign up. And of course, we were the first ones discharged. As an indication of the state of knowledge, we were told that we left Oak Ridge to go to a separation center to file a claim for radiation damage, even though nothing had yet shown up, because many of us, particularly some of the projects I worked on, the radiation doses, we took in a week what's now considered a yearly dose, etc. So I filed a claim, and one of the things I've had for many years, I think I finally threw it away when I moved last, was a letter from the chief of radiology of the Army saying, this is now 1946, after Hiroshima and after Nagasaki. There's no evidence that anyone has ever been injured by radiation, so this claim is denied. So much for that.
Oh my goodness.
after the bombs were dropped, we were free to do all kinds of interesting things. We made radioactive sulfur because the biologists we talked to could use it as a tracer. We made the one of the sort of experiments that was interesting. We made mercury out of gold, and you may question, well, that seems to be backwards. But there's only one isotope of gold. So if you radiate it and make mercury, you have a single isotope. And that means that if you make a mercury light, you get a single wavelength of light, and you now have an international standard that doesn't need thermostatic control. It can be anywhere. And so we made a few light bulbs. And we were free to do all kinds of interesting things with radiation because our job was done, what we had done. As far as security goes, again, it's a strange thing. Los Alamos was not supposed to know where this product was coming from, and we were not supposed to know where it was going. But it was something with a relatively short half-life, so we had to coordinate our production with when they wanted it. The way it was shipped by truck. There were 2 teams of truck drivers, one from Oak Ridge would take the truck to a motel in Shreveport, lock up the truck, and disappear into their rooms. A group of truck drivers, they were all GIs, a group of truck drivers from Los Alamos who were watching for it, there were multiple sets of keys. They would go out to the truck, pick it up, and go to Los Alamos. There was a third group officer who was there to make sure that the 2 groups of GIs never talked to each other. But I was supposed to not know where it was going, and they were not supposed to know where it was coming from. But we had to talk about when we were going to do it. So much for security. I don't know that it made. I never understood why it was important that Los Alamos not know where it was coming from. That made no sense at all. But then security people have their own line of rationality, I guess. It's different than mine. One of the most interesting things following the fairly soon, there was a classified international school at Oak Ridge on nuclear energy. Rickover was a student. I don't know how much you know about Rickover's background, but he'd been a real pain to the military. He'd blown a whistle on some sweetheart procurement, and they wanted to get rid of him. So they sent him off to this crazy school that nobody had any interest in. And but they also sent, the military hedges their bets, they sent 2 brand new interns to the school. Well, I was one of the people lecturing in that school. Rickover's major contribution, and it really was very unusual, I think none of us would have thought of it at all. He was a submariner. And the minute he heard that there was an energy source that did not require air, he went like through the roof. And he said, we've got to have that. And he wrote to the commanding officers of the 2 new interns and said, you know, it's difficult to keep track of people on assignment. I'm stuck here. I'll take over their paperwork if it's okay with you. And he got 2 responses saying, of course. Well, now he has 2 people whose unfitness ratings he's going to fill out. So they're going to do what he tells them. And he started to build his empire. And he went to the Navy personnel base and asked for the engineering officer that had the highest IQ of anybody on active duty. That gave him Lou Rodas, who many years later became president of Con Ed, but was him. And it gave him Bill Laney, who was a New England WASP who could introduce him to congressmen on a first name basis. And he started building his And he was not necessarily a nice man, but I know a lot of people who dislike him. I've never heard anyone identify anything that Rick ever did for himself. He really ruined his own life, his family life, but he was absolutely dedicated. You can criticize him for a lot of things, but we wouldn't have the nuclear navy if it weren't for him. And that's how that all started. If the Navy hadn't wanted to get rid of him and send him there, there'd probably never have been a nuclear Navy. Just, it's like the pinball machine thing. You've got to be able to respond. We also, one of the things after the war where Libby was at the University of Chicago, and I have no idea, and I can't imagine it's classified, but Libby kept things in his own. Libby convinced the people in power that it would be a good idea to make hundreds of thousands of curies of carbon-14. So I was still in the Army. I was sent up to Chicago, and he almost wouldn't talk to me because I was a private, and that kind of insulted him. But finally we discussed it. I went back down, and we prepared tons of beryllium nitride to be irradiated at Hanford. What it was for, whether it ever got done, I have no idea. But it was a stupid thing because it would have completely destroyed our ability to do carbon dating anywhere in the world. Because it's all done with carbon-14, and if you artificially load it, it would have been a big. So I have no idea what he had in mind. He was doing a lot of work with carbon-14, so that was my contact with Libby. Let's see, what else might be of interest. Follow on then during that period. Living conditions were very strange as far as I was concerned. I had grown up in the Midwest, and when I got to Oak Ridge, I took a bus out to Oak Ridge, got off in the bus depot, thirsty, went over to a drinking fountain, and was going to start drinking. And two people hollered at me, "You can't drink there." I said, "What do you mean I can't drink there?" They said, "You can't drink there." I said, "Why can't I drink? It's a drinking fountain." He said, "Can't you see the sign? It says blacks only." That was my introduction to the South.
So to what extent was the living and working conditions at Oak Ridge segregated like that?
You asked two questions and
Okay.
two separate answers.
All right.
The working conditions, as far as I know, were not segregated at all. The living conditions were not only segregated, worse than that, there were two compounds, fenced compounds. The gates were locked at night. Men and boys above a certain age were in one. Women and girls and boys, but younger ones, were in the other. And married families were broken up. They weren't allowed to live together.
You're talking about the treatment of blacks.
There it was segregated by your job level and to some extent your family. When I finally got out of the Army, 3 other boys and I were entitled to a D house, which was the largest house that had several bedrooms and so forth. And they made some attempt to segregate people socially by where they worked, because they really, Grove's office didn't want the people at K-25 to know why 12 existed or Oak Ridge National Lab existed. They tried to, and the reason that didn't work at all, of course, is that all 3 of those places had people that came from the same school or faculty, people that had worked together for years. They find themselves living in the same town, and, so But the black segregation was worse than segregation because it also broke up families.
And do you recall the quality of the housing that they had? Was it subpar? Was it less than what the whites had?
Oh yeah, well, it probably was no worse than what we had in barracks, except they were locked in at night and we weren't. And I think they had individual kitchens. They were in huts. The houses that the whites had were reasonably well designed and built. They were all heated with coal furnaces, and environmentally they weren't so great, but they were pretty good. The dormitory housing, I never got into the bachelor officers' quarters, but from the outside they certainly looked better than the GI barracks. The GI barracks was a standard barracks, 48 men to a barracks, and so forth.
So how did you find the social life down there? Or did you have time for that?
There really wasn't time for it until after Hiroshima and Nagasaki. The heat was off. Then it was tricky in that there were a lot of women there, married women whose husbands were overseas or in the military, and they weren't all honest about whether they were single or weren't single. So if you had any ethics, it was kind of a sticky place. I dated one of the nurses who was a local girl, and everybody knew that she was single, etc. So there was some social life. There wasn't much of anywhere to go with your social life. I know some people have said it was a dry town and you had to go way, way out somewhere to get liquor. That's not true at all, because legally the town was dry, but the guards, if you came in with liquor and they found it, they confiscated it, and you could always buy liquor from the guards. Outside of that, it was Southern cooking that I wasn't used to. When I got out of the Army and we got a D house, some other fellows, we had a local woman as a housekeeper, and her idea of cooking was if vegetables were cooked less than 3 or 4 hours, they still had poison in them. So we laid down the ground rules that she could have boiling water. The only vegetables available were frozen. She was not to put the vegetables into the water till she saw us pull into the driveway at night. And after that, she refused to eat anything in our house because it must be poisonous. So there were some interesting things to learn. There were theaters there, but it was limited social life. Then in 1948, the Atomic Energy Commission decided, like they made infinite judgments, to move the center of all of reactor research from Oak Ridge to Argonne. And Wally Zinn, who was director of Argonne, and a man by the name of Steve Larowski, who was head of the Chemical Engineering Division, Zinn agreed to accept the program at Argonne, but he would not accept transferring all of the people, because he said he's not going to let Oak Ridge unload deadwood. So the two of them came down and interviewed all of the people in the reactor program to decide who they were going to accept. Steve Larowski I had known. In fact, he'd been in the same class with Rick over at the school. And I was not in the reactor program, but he said, you know, why don't you come work for me at Argonne? We can sweep you into this program. And I said, well, I'm not sure. If I come up there, I'll be an individual researcher. Here I'm a manager of a program, 100 people, and it's good. And there's some shortcomings to living here. And what's the incentive? He said, well, because the government is making this change, everybody is getting seniority in the University of Chicago retirement system for the years you've spent at Oak Ridge. So I said, well, that begins to sound interesting. So that's how I got from Oak Ridge to Argonne. I never applied for a job. They came down there. Fairly early on, Steve had put me in touch with Zinn because Zinn had some problems they were just starting to build a first reactor, and he was concerned about iodine from an accident, needed some chemist or chemical engineer to evaluate it, and I got assigned to do that, so that's how I got to know the lab director, even though I was a peon down the road a piece. And a couple of years later, there was a accident in the criticality facility, and Fermi and Zinn decided that they really needed a safety committee, and they decided that it had to be people who worked full-time, and I was asked to chair it because I was not involved in the reactor business. And I guess one of the things which is a little bit unusual for a kid a couple years out of school, once had to tell Fermi there was an experiment we couldn't let him do. And it had nothing to do with the science. There's an experiment that today is called time of flight, where you remove a shielding plug from a nuclear reactor and you take a beam of radiation out across the countryside and make measurements. And he wanted to do that with a small reactor that we had in the park district area adjacent to Argonne, and take this beam of radiation down through the picnic area and just put a sign up at the front of the park saying, please nobody go into the picnic area in the next 2 days. And we said, you just can't do that. That's where people eat their lunches. He said, but there's going to be a sign at the, I mean, he was such a believer in, people and things. And we said no. So I had probably one of the few people that ever had to tell Fermi it was something he couldn't do. It was not really significant, but it was interesting. You can't imagine how long I stewed over. I went to see Zinn and say, can I tell Fermi he can't do this? He said, do you think it's unsafe what he proposes? And I said, yes. He said, go tell him. And Fermi did not object. He said he needed to understand why people wouldn't honor the letter, but okay. Fermi was when he left Argonne to go back to the University of Chicago, it was with a stipulation that they had to give him undergraduates to teach. He didn't want to deal only with graduate students. He wanted to encourage young people in the field, and he was an interesting guy. And so I was still chairing that committee when EBR-1 was built, and when it was melted down. Now, one of the things which has been somewhat lost in history, the difference between a sodium reactor and a water reactor. Here was a reactor that had a complete fuel meltdown, similar to Fukushima or Chernobyl. But sodium is so chemically active that no iodine escapes. Even when you melt all of the fuel, it becomes sodium iodide, which is what's in your sodium salt shaker. That reactor, after we got all the molten fuel out of it, was cleaned up and replaced with a plutonium core, and the reactor ran a few more years, even though it had a complete core meltdown. The There's a big difference. The are you aware of the SL1 reactor? It's the one, the accident that killed 3 GIs.
You want to talk about that?
The military plan was to put a ring of radar stations north of the Arctic Circle, and they needed to figure out how to power them. The weather up there is such that you could fly in there only like 4 or 5 months out of the year, stockpiling enough oil for a year. It wasn't practical. A reactor was the obvious answer. So they built a prototype, asked Argonne to design and build a prototype of a reactor that could be, from day one, somebody said, I want one right here. Within 6 months, it could be up and generating power. And on a new site, et cetera, et cetera. And it had to be really a hot rod, because most nuclear reactors, when they shut down, cannot immediately be restarted. There's a isotope called xenon that grows in, and it's a poison. You have to wait till it dies out. But if you have enough excess reactivity, you can override it. And that makes it a hot rod. And these units had to be hot rods because if the reactor went down, the people would die, because it provided heat for the buildings, electricity. It was their only energy supply. So they really had to be hot rods. After about 9 months of operation, we were training Army crews that had early nuclear training at Fort Belvoir, and then came to Idaho to train on this reactor. And the Army came to Argonne and said, we don't want Argonne supervisors on the 2 back shifts anymore. We just want the military people to run it the way they will be running it. You can have an Argonne supervisor on day shift. And I and one other member of my committee went to Fort Belvoir, talked to the people that were doing the selection of people, studied their training, and came back, and I told Zinn that I said, I don't think we should accept responsibility without a supervisor overseeing these people. These are not necessarily the kind of people that we would pick and train for reactor operators. So there was a stalemate, because the Army said it's our reactor, and Argonne said it's our safety. So the way it was solved is Combustion Engineering agreed to they took over the contract. It was transferred from Argonne to Combustion Engineering, because Combustion agreed to not have people on the 2 back shifts. Less than 6 months later, there was an accident, and all 3 operators were killed. And I'm not going to tell you what happened and why it involves people, because there are all kinds of issues of liability, and it never really got on paper. One of the interesting fallouts, the question did come up, is being a reactor operator a dangerous occupation? Should it have hazard pay? And I was asked to do a study to evaluate that. And I stewed quite a bit, because I didn't know how to do it, because what am I comparing? We finally decided that we would evaluate life expectancy of a coal plant operator with a nuclear plant operator, because they were sort of the same level job and similar skills, etc. And we interviewed everybody that had reactors, went again to Fort Belvoir, went to England. The British had an interesting position. They hired as supervisors for their reactors only retired nuclear Navy chiefs, because someone who could spend 30 years preparing for an emergency that never came were the kind of people they wanted to run their reactors. When our report so we compared life expectancy of coal plant operators with nuclear. When the report got published, I started getting all kinds of hate phone calls, and how could you? And I said, did you read the report? No, all we read was the abstract, the front. We're not going to read it. I said, well, you read the report, because what the report says is that life expectancy of a coal plant operator is 3 years longer than a nuclear plant operator. But the reason is coal plant operators drive on the average 3 to 4 miles per day to work. A nuclear operator drives between 35 and 40 miles each way on the way to work. And the accident rate from that extra driving swamps out everything, the black lung, any and all other risks. So unfortunately, we and I include myself, almost everybody has a very poor evaluation of what risks are really risks. There's a lot of concern about occasional accident with a driverless car. The last 5 years, I think the statistics are that 94% of the accidents leading to deaths were due to human error. So if you have a 1 or 2% accident from a driverless car, don't get upset about it. But anyway, then we can fast forward. I guess you want my whole career?
You have a fascinating career, and it's kind of a career that reflects a lot about the industry, the power industry, because that's where you ended up. So.
I had very active roles both in TMI and Chernobyl. I can go fast forward to the 70s. I'm now associate lab director at Argonne. I'm not the bottom man on the pole anymore. And Chauncey Starr comes around and says he's starting the Electric Power Research Institute, EPRI. I don't know if you're familiar with EPRI. Do you know why it was formed? That's an interesting story. At a national meeting of the regulators, they had decided that they were going to impose a requirement on all utilities that everything they buy had to be at lowest bid. They could no longer do sweetheart procurement. The consequence for that is all of the manufacturers, Westinghouse, GE, all of them, started reducing the quality of their products because to be competitive, they couldn't have an extra 10% copper in their transformer or something. So the utilities decided they had to have somebody on their side. So a couple of utility CEOs got all of the utilities of the country to sign up. It was amazing. Not only the privately owned utilities, the government like TVA, the rural electric co-ops, and they formed EPRI. Chauncey Starr was hired to be its first president. Chauncey came and looked me up at Argonne and said he'd like me to come work for him and head a division on risk assessment. And I said, well, it's interesting, but I'm not a risk expert. I'm not the right person. So he went away, and about a month later he came back through Chicago. We talked for an hour. He said, if you come to EPRI, I don't know where it will be, and I don't know what the budget will be, but I'll give you 25% of the staff openings, 25% of the budget, and you put in place any research program you think utilities need for nuclear plants. How do you turn that down? How EPRI got formed is it could have been located in any one of the 48 states because all the utilities were supporting it. So they hired, I think it was McKinsey, one of those people, to do a study. They got 200 names. There is a registry of research scientists. They got 200 names from it, and they did a double-ended survey. They asked two types of questions. What city do you think is a good place to live that you'd be willing to take a job there even if it wasn't a real promotion? And which cities would you not be willing to move to even if you got more money and a better job. They asked about 40 cities. 2 were way out the bottom. Nobody wanted to come to New York or Washington, a research scientist. There were 36 in the middle. You couldn't tell the difference between Los Angeles and Kansas City and Minneapolis, but there were 2 out the top, the Bay Area and the Denver, Boulder, Colorado area. So when I accepted the job, we might have been at one of those 2 places. I hadn't decided where yet. Chauncey imposed another requirement that we be near a university that would give us access to their computer and library the day we opened the doors until we could build our own, and would offer adjunct professorships to people that were qualified. And so we might have been at Berkeley, we might have been in Denver, but then the utility chief executive said from day one, EPRI has to be an entity. We don't want to go into a building and look down an index and say they're on floor 15. There was a relatively small building on the Stanford campus that was for sale, and one of the Silicon Valley outfits that was growing and wanted to sell their building, Stanford was willing to cooperate. So that's how EPRI got there and how I got there. Now we fast forward to TMI, and I got a call from Herman DeCamp, who's the president of the utility. And the day of the accident, he said, Milt, something is going on. I don't know what it is, but I think it's serious. Can you come here? So I flew that night to Harrisburg, and over the next month, 100 technical people volunteered. They came from some universities, from some big companies, from all over, and I was asked to take charge of that group. So I stayed there for 30 days providing technical support. We had I don't know what it was. It wasn't a committee. It wasn't. There were 5 of us that met twice a day. 1 person from the utility, 1 person from the architect engineer that had built the plant, 1 person from the Nuclear Regulatory Commission, and me, who was the 5th. Anyway, we met twice a day. Every morning we'd go over what information we had from the night before and what can we do now, how do we secure the plant. It took close to 30 days to get the plant stable on natural convection where you didn't have to do anything, which is why I stayed 30 days. And the president had told the Nuclear Regulatory Commission to not talk to anybody. The utilities lawyers told them not to talk to anybody. The Europeans were in a fit because they had American design reactors. They had no idea what had happened. So I got a call. There was a European Nuclear Society meeting coming up in Hamburg. Would I come there and tell them what had really happened? So I went there and spoke for a couple of hours, and the Germans carried it live on all of their national TV programs, the whole thing, because the people were panicking and fearful, and there was nothing to be afraid of or panic. And then I flew back to California. The interesting sidelight is I made 3 round-trip airplane flights. There was the original one, and then when it was clear this wasn't just a few days, I flew back to California to get more clothes, and then I flew to Hamburg and back home. And those 3 airplane flights gave me more radiation than the operators who were inside the plant at the time of the accident got. Things are strange.
Okay.
Some of the paper in Harrisburg published some horror stories and claimed that there'd been cows with 2 heads born because of the radiation, on and on. And local people sort of believed it. But these identical articles appeared in papers in the Ukraine after Chernobyl, published in Russian. I had them translated because I'll if you're interested in that part of my career, I can tell you about my involvement there. But the governor was under real pressure to evacuate. There was clearly no need to evacuate. The NRC said you don't have to evacuate. The lawyer's own technical staff said you don't have to evacuate. But he was under pressure. So he said pregnant women and families with small children can evacuate. The local people called it an evacation because they could stop at the utilities office and pick up a check and go out. It's been said nobody died as a result of TMI, and I don't know this as a fact, but I've heard it, that that's not correct because one family took their check, went up and rented a houseboat in the Poconos, and a toddler fell off the boat and drowned. And if the family had not evacuated, the child probably would have been alive. At Chernobyl, the evacuation caused hundreds of deaths. And when we get to that part of the story, I'll give you the bottom line. The World Health Organization at the 25th anniversary published their final report on Chernobyl. And they say that the maximum long-term health effect was the evacuation of tens of thousands of people. There was no need to evacuate. Men thought they were sterile, committed suicide. Women had backroom abortions, afraid they were going to give live to monsters. So there's 40 men who died, the firemen, and then there are the hundreds that died due to the evacuation. The Japanese are seeing the same thing, slightly different political things, that in their culture, people won't have anything to do with people that lived near the plant. They're outcasts, and there's all kinds of psychological problems and people committing suicide. That there's, from a technical standpoint, there's almost never any reason to evacuate. The big difference, for instance, between Chernobyl and, I don't know if you're familiar with the accident the British had called Windscale. They had a complete accident. And the big problem when you have a release of radioactivity is the iodine, which gets into the milk and you have childhood thyroid cancer. The British purchased all of the milk for 90 days, made it up into cheese and butter, and after 90 days the iodine is decayed away, it's okay to use it. After Chernobyl, the Russians told people, don't let your children drink the milk, but peasants didn't trust the government. They let their children drink the milk, so there were some hundreds of cases of infant or childhood thyroid cancer. I think there's only been 2 or 3 deaths because youthful childhood cancer, thyroid cancer, is largely curable. In most cases, clearly the thing to do is turn off your air conditioner, close your windows, just stay in your house while the cloud goes by. Because if you get out on the road, what are the odds that the wind is not going to be blowing the same way you are, and your game being more exposed? Well, anyway, that's a whole separate world. And in fact, the containment building, there's a lot of published stuff about TMI. One of my final reports was not only published in a U.S. journal, but the IAEA translated it into all of the UN languages and distributed it throughout the world. Because we suddenly realized that all of the computer codes were off by many orders of magnitude because of what had been ignored. In TMI, it was in a containment building, but it probably wouldn't have mattered whether the doors were open or closed because it rained inside the building for over a week. The heat boils up water, it condenses on the concrete, on the steel, on the piping, and drips. And it scrubs all the radioactivity out. Even if the doors had been open, none would have gotten out. And that is such a complex issue. It's never in the analysis. They assume if it comes out of the fuel, it's outside. And we now have there have been 12 core meltdown accidents in history. You probably don't know about all 12, but there are 12, not 2. and one in England at Windscale, one in Czechoslovakia, one in France, 2 in Canada. It adds up to 12. The
And the result of all these was
not a single civilian has been died as a result of the accident, except the children thyroid situation in Chernobyl. The only, and I say civilians because the 3 military people were, and then there were the 40 firemen at Chernobyl. What they died of, I don't know. I'll tell you how I know some of the things I know about Chernobyl, but I've seen the autopsy pictures of these people. Most of them had from 30 to 50% of the skin burned off their bodies. The firemen in Russia had the same kind of protective gear that sort of your butcher has. They had a cloth smock and a plastic face shield. They didn't have leather jackets, leather pants. They didn't have Scott air packs. They didn't have helmets, and so they were. Now, that's a whole separate. And in fact, I was involved when Clinton was president in arranging to provide some specimen sets of firemen protective gear to the Russians. We didn't have to provide them a lot. They could duplicate it. But there's an interesting story in connection with that. We made arrangements. It was between Gorbachev and Clinton, and I got involved, and we sent the stuff over there. About that time, the Soviet Union had broken up, and they were doing what the American economists told them, which was privatize everything. So one of the first things they privatized was customs, and they held up these firemen gear. They wanted duty paid on it, and the U.S. said, "Look, we're giving it to you. We're not going to pay duty." The people at the plant had no money, and we had to go through the White House and through Gorbachev and around. And finally, they would release it, but they wanted to get paid for the storage on it. How complicated the world is. Now, if we fast forward to Chernobyl. In 1974, there was a whole series of meetings on international nuclear power in Geneva. I'm familiar with those. I had attended several, and one year there was a disagreement between the Russians and the Americans, and it was going on, and I was getting bored. It was in the field of reprocessing, and so I just was turning my switch to the various languages, and we were talking about a reducing agent, and I heard the Russian say salt. No, we were talking about salting agent, and I heard the Russian say reducing agent. So I interrupted. They didn't have a word for salt. I interrupted everybody and said, "Wait! We're not having a disagreement. There's a language problem." And partly as I don't know that was the only reason, but as a result, the head of the Russian delegation invited an American group to come to Russia and see everything in their sodium reactor program, because that wasn't part of the military. So I went there in 1974, traveled all over, and one of the places we visited was where their 600 megawatt big BN 600 was being built, but on the same site was a prototype for Chernobyl. So in '74, I had seen a prototype, so I was familiar with the concept. Now we fast forward to '86. I'm in South Korea. Chernobyl happens. That far away from home, I'm obviously an expert. So I appear on South Korean TV, interviewed for a couple of hours. People send in questions. They're asked in Korean. They're translated to English. I answer in English. They're translated back into South Korean. The next morning, I go in to pick up some clothes from a tailor I'm having made, and he's all excited. He's got my picture in the window, and because now he's got a celebrity as a client. And I said, Mr. Lee, did you hear me on TV? Oh, yeah, yeah. He said, I'm not worrying anymore. Okay, okay. I said, well, double translation like that, what did I say that makes you okay? He said, Russian reactor full of carbon, South Korean reactors like American full of water? Big difference, I understand. And in fact, he was fairly close to what was right. But on the way home, I stopped in Japan for a couple of days at R&R, and on the Japanese television, they had pictures. The Russians were flying a helicopter over Chernobyl, taking pictures, and radioed it to a ground station. Japanese had somehow intercepted some of those pictures, and they were on TV. And one of them was a nearby building where there'd been a big fire, and there was a graphite stringer on the building. And the Russian concept, the official version, was there'd been an explosion which blew the top off the reactor and stuff spewed out. The top weighed close to 1,000 tons and was 10-foot thick concrete. It has a certain time constant. It takes a long time for it to move. Graphite is very brittle. When I got a copy of the picture from the Japanese TV, blew it up, you could see machining marks on the graphite. Graphite wasn't damaged at all. That physically could not have happened because the graphite would have hit the underside of the cover and crushed. There was a big meeting coming up in Vienna with the Russians were going to tell what happened. And I was going to be a member of the team, but about a week before the AEC, I think it was AEC, or was it DOE, it doesn't matter. The government decided so many people wanted to come from the government that no outsider could come, so I got scrubbed. But the ANS was one of the only non-countries accredited to the IAEA. So I sent a letter to Hans Blix and said, the ANS would like to have 2 participants. And he came back and said, every country wants more, we can only give you 1. That's fine, that was me. And it turned out to be the best thing that could have happened to me because Legasov, who was head of the Russian delegation, was under strict orders from the KGB to not speak to the media or to anybody from any country. Well, I wasn't from any country and I wasn't the media, so he agreed to talk to me. And I talked to him and told him why I didn't believe the official version. And I asked him, over the years, my language skills are very limited, but I've discovered that one of the things translators do badly are the titles on charts and graphs. They almost never get that right. So I asked if I could see his copy of the book. I had an English translation version to just make sure they were right. And I recognized that his book had some missing numbers, 13, 14, 18, 19. They weren't numbered the same as mine. I've later discovered the original version of the book, they had, it might be this and it might be that. And the KGB or somebody had said, you can't go to Vienna and say you don't know what happened. So they had revised it to have a single thing. But Legasov invited me to come to Moscow. And I went to Moscow and talked to them, and it was really very interesting. It wasn't clear they weren't going to say anything or what. When I got home, I find that I have an invitation. I don't know if you have any idea what the status was of Sicily during the Cold War. There was a conference center at the city of Erice that I think was built with mafia money, but it was an odd place. The Russians could get there without visas, and the Americans could get there. This meeting I was invited to, the invitation came from someone at the Livermore lab, and I don't know why he invited me, because the purpose of that meeting was there were people from Livermore and Los Alamos meeting with Velikov, who was Gorbachev's science advisor, to discuss how could they convince politicians that nuclear disarmament was a good thing. And so I met Velikov at that meeting. There were a lot of other things that went on at that meeting. They aren't classified, but they're a little sensitive for some of the people involved, so I won't go into detail. But there was a lot of meetings of people of different countries there. But Velikov asked me, he said, you know, we know the Americans could help us, but the only people I can talk to are in State Department and DOE, and they don't have any technical competence. He said, you know, we're frustrated. I said, well, if you had something like a nuclear society, you could have meetings with the European Nuclear Society. He said, what's a nuclear society? Tell me, we'll have one tomorrow. And so they, you know, went to each plant, you were members, etc. And they asked me to serve as liaison to their board, which I did for 10 years. Made 2 trips a year to the Soviet Union. And Velikov and I agreed that the public display going on in Vienna was not really a purely technical assessment of what was going on. The questions people asked were obviously from bigoted sources. It would be highly desirable to get an assessment of the accident that was just technical people. And so he agreed to sponsor a meeting at Sochi. He picked 15 Soviets. I picked 15 Americans, and together we picked 15 Europeans, and we spent a whole week going over the accident and what might have happened. And the people I picked was a complete spectrum. There was one biologist, just everything. And they put a Aeroflot plane at our disposal. We went up to St. Petersburg to the Radium Institute because they were the people that had done the analysis on the samples from Chernobyl. It was a very complete, thorough study. And by then I had conjectured what must really have been the true cause of the accident. But I didn't know what to do with it because we were still in the Cold War days. So I go to Dick Kennedy was the Kennedy and who became an ambassador. He was a member of one of the original commissioners on the Nuclear Regulatory Commission. The reason he became an ambassador and he was in state is when presidents went to some country to discuss a nuclear matter, they wanted somebody of ambassadorial rank. The ambassador to that country was seldom competent. So he was an ambassador. So I called Dick and said, what do I do with this? You know, it's based on my experience, some of which is classified, some of it isn't. He said, well, the head of administration in the IAEA is always an American. Why don't you send him your idea and your thoughts? He said, the security at the IAEA is such, it'll probably be in Moscow within hours of his getting it. And in fact, I got invited to come back to Russia and discuss it. The Russians publicly never admitted that my idea was right, but the retrofit they did to the plants was based entirely on my solution. And so the original cause of the accident was not an operator error. It was a phone call from a dispatcher. They got a call. They were in the process of shutting down the reactor. Oh, the RBMK is a very unusual monster. Now, I had the experience, had the background of having seen the prototype, so I understood the concept. the prototype had been designed by an academician. In the Russian system, nobody tampers with what an academician done. So when they wanted to make a big one, they took all of the dimensions, same dimension of a piece of graphite, same dimension for fuel, and instead of 160 channels, they made 1,600. As a result, they have maybe 8 or 10 nuclear reactors inside one shielding wall with one set of control rods. It's like the difference between riding a single horse and having a team of 50 horses to control. As a result, the operating procedure for the reactor had only 4 conditions: completely shut down, completely at full power, or going up or going down, which was absolutely rigorously controlled at rates. And that's all the operators were trained on. It's all they were allowed to do. They were in the midst of a shutdown, normally scheduled shutdown. They were doing an experiment. Same experiment's been done many times in American reactors. They got a call from the dispatcher saying there'd been an accident in a hydro plant. They desperately needed the power. They should just stop where they are. And he held them at half power for like 48 hours, I think. In the meantime, xenon has been growing in, and when he releases them, they go to start their procedure for shutdown. But they now have a reactor that has completely different physical characteristics. So their control rods don't do what they're supposed to. Nothing happens right. You could hardly blame the operators. And there's a whole, get that level of detail, things that caused failure. But what happened was really a steam explosion, which blew the lid off. When the lid blew off, all of the water shot out of the reactor. Then it went critical. And then the nuclear explosion was a consequence, not the originator. Now the lid for the reactor and the roof of the building are already gone when it goes critical, so it can throw out intact pieces of graphite. And just from a fluky picture on Japanese TV, if I had not seen the prototype, would I have come to the same conclusion? I don't know. Can't tell you what you base your past on. But as I say, I spent 10 years, twice a year, and so I've been talking for a long time. Now I'm in a completely different world, and haven't had nothing to do with nuclear weapons for a long, long time. Oh, I might tell you about my last job change, because that was sort of interesting. I was set at EPRI for the rest of my life. I was going around the country lecturing, saying that the problem with nuclear energy was not overregulation. The regulators had something to blame, not that they were overregulating, it's the fact that they weren't stable. You couldn't depend on them. But the architect engineers had part of the blame, the utilities had part of the blame, and the vendors, there was enough blame to go around. The head of one of the largest engineering firms in the country said if he heard me give that speech one more time, he'd punch me in the nose. I got a call from Bechtel offering me a job. Ken Davis, who had been working for Bechtel, had just been appointed by the president to be Deputy Secretary of Energy. So his job was open, and they offered me his job. So my last transfer, the man I went to work for, Harry Reinsch, was president of Bechtel Power. I also did a number of things for Steve Jr. And so it was a good closeout to my career, so to speak. Then, just a few years ago, when I retired, a lot of people contacted me, but I felt they just wanted to put my name on a proposal. I decided that the only consulting I would undertake was if I thought I could contribute and it interested me. And I got approached by the people in the Nuclear Explosive Safety Division of NNSA, the safety reviews at the Pantex plant, and there are many. You know, there are many different types of nuclear weapons. I think close to 100 different types that were made. Most of them are long gone, but any type weapon they haven't worked on in the last 18 months or so gets a complete review. Every 5 years, everything gets a complete review. And I really mean everything. It can be up to a month. And the reviewing committees are always the same. There's one person from Livermore, one from Los Alamos, one from Pantex, one from Sandia. The chairman is a Fed. And then there are two outsiders called senior technical advisors. And I was offered me to consult as one of those. So I am. And it's the level of concern. It's one part of DOE that functions very efficiently. The level of the procedures that the technicians have is beyond minutia. And there's minimum of three technicians. One is a reader. He will say, get a number 7 screwdriver. And the other two technicians will say, understood. One of them will go get a number 7 screwdriver, show it to the other technician. It's a number 7, and there's a date on it. It's been inspected, so the handle isn't loose. It's still within it. Then the reader will say, take the 2 screws out of the top. The one technician will do it. The second technician is watching the first technician to make sure he doesn't accidentally or purposely do something other than what the reader just said. So watching him take apart a nuclear weapon is like someone once said, how do porcupines make love? Slowly and carefully. But it's really very boring, but we start out getting a couple of 1,000 pages of the history of that type bomb. The records when they were built are really very good. The things that you're not so sure of is what's happened to the weapon since. Was it stored in somewhere like Africa at 120 in the sun? Was it stored at Greenland at 65 below zero? There's lots of components in a weapon besides uranium or plutonium. And the electronics and the conventional explosives tend to age differently. And so it's a very careful, slow-going procedure. But it's what I find interesting. There's a lot of, in the procedure, what people do are human factors. And one of the things I learned a long time ago is when we talk about systems analysis, every system has 3 components: hardware, software, and people. And you better know about the interaction of all 3 if you want to know what's going on. But it's been an interesting few years, and I'm still doing it.
That's terrific. Well, let's just pick up on a few things we talked about before we started your chronological progression here, because I don't know if you're worn out yet, but you had raised several topics. One was sort of the people that you knew, and you mentioned that Leo Szilard was someone that you were sort of.
Well, because one of the things that goes first are proper nouns and names. I earlier today made a list of the people the names that I've had some. I've mentioned Rickover, Libby, Near. Vigner was my boss at the Oak Ridge National Lab, up a notch, and it would be interesting. He would come into the lab and walk on, ask what you were doing. I had no idea. He was not so strong in chemistry. That wasn't his field. And although I think his formal education in Europe was as a chemical engineer, not a physicist. But anyway, he would ask, oh, what is it you're trying to do? And okay. He'd turn, start to walk out, and almost without exception, he'd say, have you thought of this or have you tried that? And it always could contribute. And as I said, you could never walk out the door behind him if you were going to say, well, he was the gentleman always on everything that he did. I've also mentioned Fermi, I've mentioned Teller, I've mentioned Szilard. Szilard was an incredible man and a very interesting. One night we were having dinner and my brother-in-law said, Leo, I heard you finally married your wife, you know, name escapes me again.
Trudy?
Uh,
Trudy?
Trudy. I hear you finally married Trudy. He said, who told you that? He said, well, I think Herb Anderson told me. And Leo said, well, he's pretty reliable. Maybe it's true. But you never, I mean, we'd be sitting at the dinner table and Leo would be talking to my brother-in-law about something they were working on. He talked to my wife and sister-in-law about some item of the day and talked to me and be carrying on 3 conversations on 3 different topics. And then all of a sudden you'd look around and Leo was gone. He would never thank his hostess. He just would get up and leave all of a sudden. But there's so many things that he's really responsible for that he never got credit for. Just he was really deep thinker, and some of the people were, you know, geniuses, but in a narrow field. But he was very unusual, and I keep comparing people like Eugene Wigner and Leo Szilard and even Hans Bethe with Teller, and you know, the most interesting thing, anybody ever figured out how these 5 geniuses came out of the same school in the same small town in Hungary? The 5th member, you may or may not know, was a director of symphonies. If you add up the people like von Neumann, and normally people talk about 4. There are 5 geniuses from that class. The 5th one is a European concertmaster.
Wow.
Our education system could maybe learn something.
Right.
I'm sorry, you had.
No, actually, you also mentioned the Japanese reaction to Hiroshima and how the scientists had calculated that it probably the last uranium bomb.
Oh yeah,
Talk
I don't know this firsthand, but I've heard it from sources that I think were fairly reliable, including some people in Japan who thought it was correct. I've been to Japan a fair number of times. I've lectured at Toshiba, and I have Japanese friends there. After the first bomb was dropped, it wasn't very long, pretty short order, the Japanese physicists came to the conclusion it had been a uranium bomb. I mean, they had debris sample stuff they could sample, etc. And it was a uranium bomb. But looking at what it would take from first principles to separate that much isotope separation, etc., they came to the conclusion that the amount required, probably the minimum amount to make a bomb, was probably pretty close to the maximum amount that the U.S. could ever produce. So there was no reason to capitulate because this was a one-on, it wasn't going to be any worse. They had no idea, of course, about the plutonium bomb. When the plutonium bomb came, then the whole whole picture changed. But again, this is hearsay, and I'm not sure how reliable it is that the Japanese are having a lot of problem, just like the Ukrainians have with the people that were evacuated. We know that somewhere around 50 people who were in hospital beds died because they were too ill to have been moved. And but how many other people are suffering? I mean, there's another thing where the culture is not that different. In a place like Russia, the people that live in a village and have lived there for centuries and generations, you pick them up and move them 50 miles, that destroys their life. And there's probably some of that also in the Japanese, although the Japanese, the younger generation has become more mobile, but it doesn't surprise me to hear that there's lots and lots of psychological damage and suicides. Now I don't have no firsthand knowledge of that, but it would seem that it was so universal after Chernobyl that it probably was also true.
So do you, from what you know, believe that the evacuation in the area around Fukushima was not necessary?
That's right. There's no reason to believe. I mean, let me put it this way. It's now, what, 10 years or so on, etc. Not a single one of the people that was in the plant and remained in the plant has any indication of radiation disease. So for people outside the plant, no way. Do you know one of the human factor stories was why the other plant that's nearby was not damaged? Do you know?
Tell us.
Okay. The plant that was damaged, and this is partly a cultural thing, and it's, again, this is not firsthand, but I think it's pretty reliable. Plant manager had some emergency procedures, but he didn't know if he was authorized to implement them or not. So he tried to get a hold of a supervisor by phone to decide whether he was authorized. And of course, the phone lines were all down because tsunami, etc. At the other plants not far away, the supervisor recognized he had a problem. He had no power. He had about 100 employees in the plant, all of whom had driven to work. He sent them out. They took all of the batteries out of the 100 cars and hooked them up in series for a power supply to get emergency cooling. That plant did not melt down.
Oh, wow. That was clever. Wow.
Yeah. It's really, it's the culture is why these two people did two different, don't know. You know, how you predict people are going to react in an emergency, we know very little about. I know from some work I did many, many years ago with the military that they've kind of given up on trying to determine when they put people in charge of a squad or something, who's going to react properly in an emergency. They just...
And you can't predict.
They can't predict.
That's very interesting. You said, you also were talking earlier about the effects of radiation on the victims at Hiroshima and Nagasaki.
Mm-hmm.
Why don't you talk about the study, the joint U.S. and Japanese study, and what they found?
Okay. Everyone knows a large number of people were killed at Hiroshima and Nagasaki. Not very many people know that even more survived. There's a center at Hiroshima that is jointly funded by the Japanese government and the U.S. government, administered to some extent by the National Academy of Sciences of the U.S. And they've been following the survivors, the children, the grandchildren, the great-grandchildren, all of the people involved. The first, one of the most important things was the concern about genetic damage, mutations in the future, and so far it appears that no such thing has been discovered. Women who were pregnant when they were irradiated at these large levels did have stillbirths and all sorts of problems. Of the women and the descendants of the women who were not pregnant when irradiated, their pregnancies have all been normal. One explanation for this is that the cells that are mutated turn out to essentially all be sterile, so it doesn't transmit. The life expectancy of those who survived has been determined to be somewhat longer than those of the average population. That doesn't mean the radiation was good, because we don't know whether maybe the healthier ones survived or they've had better medical care, but it's pretty clear that there is no significant life shortening due to the radiation, etc. There is just recently some indication that there might be a very, very slight increase in cardiac incidents 50 years after they were irradiated. That there's what happens is the radiation, some cases, causes the heart to thicken a little bit. When the heart thickens a little bit, it becomes more resistant to the electrical signals, and in extreme cases, it just no longer can get the electrical signals. But that's at the very limit of statistical analysis of thousands of people, and maybe you find a couple. But all of the horror stories are nonsense, and it takes large amounts of radiation. I've seen estimates that the amount of lives saved per year by the use of radioisotopes now exceeds the number killed in Hiroshima. There's one isotope alone, Tech-99, that over 1 million patients a year get treated with in the US. They estimate it reduces death of heart attacks in emergency rooms by 60 or 70%, because it used to be if you came into the emergency room and had serious pain, maybe they could agree to put a catheter up through a vein and find out if it's plugged, and maybe they could find it, maybe they couldn't. With Tech-99, they give you an injection. The Tech-99 is attached to something that sticks to plaque. They take your picture, and they know if a vein is plugged and where it's plugged. And that just is that's why there's a whole big issue right now, because all of the Tech-99, essentially all the Tech-99, is made outside the US. It used to be made in the US, but Carter, I think it was Carter who shut it down. But anyway, and after 9/11, when the airplane stopped flying, it has a short half-life, it didn't show up. So the medical profession has been working very hard, and Congress has finally put up some millions, tens of millions of dollars to help subsidize some American company to get into the business. And I think there are now 4 candidates that are trying to develop a process, because it's considered critical for national safety to have now there are a lot of people that say, it would sound crazy to say there's a radioisotope you have to have for health. But in fact, you go look at the Tech-99. The thing which is unusual about it is you could attach it to anything. So you could attach it to something that's going to go to the thyroid, something that's going to go to the spleen, something that's going to go to the brain. In low concentrations, it's diagnostic. High concentrations, it's therapeutic. So that's why there's millions that we've been importing ours from Holland, Belgium, South Africa, Australia. more and more countries around the world are building reactors purposely just to make technetium-99.
The Y-12 plant used to produce a number of radioactive isotopes.
Yes, but not Tech-99, they can't.
They can't.
What they produce, they don't produce radioactive isotopes. What they do is separate mostly a lot of isotopes. But it takes something like a reactor to make
Yeah, right.
nuclear.
Yeah,
And
so I guess
Y-12 doesn't have reactors.
Right.
that-
That's what
yeah.
X-10 was used for then, for medical
Yeah,
isotopes.
yeah.